Welcome students. Today we are going to know about the Stefans law of radiation. But before knowing the Stefans law of radiation, it is most important to know that this law is applicable only for the perfectly black body. Perfectly black body. Okay? This law is strictly applicable for the perfectly black body. And what exactly is the law and what exactly is the statement? But before knowing the statement, we'll have to know, in the previous session we saw emissive power. Emissive power E is equal to Q upon AT. This formula already we saw. Amount of energy radiated per unit area per unit time is nothing but emissive power. The unit of that one is a joule per meter square. Here is the time, that is in second. Means Q it is measured in joule, A meter square, and T time, that is in second. This is emissive power. What about the next? That means coefficient of emission. Coefficient of emission. Or we can also term as a emissivity. Okay, this is another term. Now this emissivity E is equal to this ratio, a ratio of similar quantity, no unit. Emissive power of a general body to the emissive power of a black body. Means in terms of E, we are going to express that E is equal to E into EB. This is another relation that we are need to utilize in this equation. See once again, the emissive power E is equal to Q upon AT. Amount of energy radiated, emitted per unit area, per unit time is nothing but the emissive power of the body. So it is Q measured in joule, area meter means area meter square, and time in second. Coefficient of emission, it is a ratio. We can term that also as a emissivity. So emissivity or coefficient of emission is the ratio of emissive power of a general body to the emissive power of a black body. Ratio of similar quantity, no unit. So E is equal to E into EB automatically. What about the Stefan now? Come toward the point. According to Stefan, or this law is also known as the Stefans-Boltzmann law. Before knowing the Stefans law, the statement is as follows. Amount of energy emitted per unit area per unit time is directly proportional to T raised to power 4. Fourth power of absolute temperature. Once again, amount of energy emitted per unit area per unit time is directly proportional to fourth power of absolute temperature. The statement has been given by the Stefan. So this is nothing but your emissive power. Yes, obviously we can term that emissive power is directly proportional to fourth power of absolute temperature. This is the one of the statement. But what about this constant of proportionality? We'll have to take, so as to discard this constant of proportionality mark. So constant we'll have to take. So Q upon AT is equal to sigma into T raised to power 4. What about this sigma? Sigma is nothing but the constant known as the Stefans constant. Stefans constant. This is known as a Stefans constant. So what about the Stefan constant and value of that one? It is given by sigma is equal to, very easy to remember, 5 0.67 into 10 raised to power minus 8. What about the unit? Unit, don't remember, it will forget. You will have to obtain, here it is, sigma is equal to, all the terms we are going to take as in a left hand side or either maybe right hand side, collecting all the terms, q upon a t as it is, and this t raised to power 4. So unit of that one is a joule per meter square, joule per meter square second. Okay, t raised to power 4 means a second raised to power, here it is, here second into Kelvin raised to power 4. Or either, again we need to write, here it is, joule per meter square second raised to power, or Kelvin raised to power 4, or watt per meter square Kelvin raised to power 4. Why? Joule per second is nothing but your watt. So this is all about. Sir, is it over? No. Still we'll have to modify the equation. Here, this is for the perfectly black body. Once again, for the perfectly black body, amount of radiation emitted by the black body having some sort of area, okay, maybe any shape, having the area A, and amount of energy radiated in all possible direction is nothing but amount of energy radiated per unit area per unit time is nothing but emissive power, which is directly proportional to 4th power of absolute temperature. So this is all about. This is sigma, known as the Stefans constant, so as to discard this constant of proportionality, and sigma has a value 5.67 into 10 raised to power minus 8. In NEET, we are going to utilize this value as a 6 rounding, 6 because it is more than 5.5. So 6 into 10 raised to power minus 8, and unit is before you. This is 1 unit and this is another unit. We have to remember both. Important for the CET. So here it is, Q upon T, here is another term, or Q upon AT is equal to sigma into T raised to power 4 for a perfectly black body. Perfectly black body. Which body? Black body. Okay. What about the ordinary body then? Very simple. As we know, this is nothing but your E, and E into EB. Already we know this is EB because it is for the perfectly black body. Once again, see, this is for the perfectly black body. So EB is equal to Q upon AT, no doubt. This is for the perfectly black body. Instead of that, okay, just a symbol, that is EB. EB is equal to Q upon AT, which is equal to sigma into T raised to power 4 for perfectly black body. For the ordinary body, obviously E is the ordinary body. So E, if it is E, then Q upon AT is equal to E into sigma into T raised to power 4 for ordinary body. Ordinary body. This is all about. Sir, is it over? No. Still we'll have to get few more equations as follows. As we know, for the perfectly black body and ordinary body, Q upon T is equal to, here only A which is absent is taken to the right hand side, sigma into A into T raised to power 4 for black body, or we say perfectly black body, perfectly black body. Okay, and what about this? Q upon T is equal to sigma E into sigma into A into T raised to power 4 for ordinary body. Ordinary body. Sir, is it over? No. Still we will have to obtain few more equations. As we know, surrounding temperature, if we need to consider, or outer temperature, it need to be considered as a TO. With respect to the outer temperature, what about the Q upon T? What is this Q upon T? That is very important. So it is given here, Q upon T is nothing but power of radiation. Power of radiation. Ability to do the work within a given time is known as power. And that power in terms of calorie, in terms of joule, we say that Q upon T is nothing but the power of radiation. This power of radiation, both the power of radiation is equal to sigma into A into T raised to power 4. But always the power, it is radiated to the surrounding. So with respect to surrounding, what is the formula? So Q upon T is equal to sigma into A into T raised to power 4 minus T0 raised to power 4. For which body? Perfectly black body. Perfectly black body. And what about the ordinary body? You can tell me easily. This is nothing but your power of radiation. So Q upon T is equal to E into sigma into A into T raised to power 4 minus T0 raised to power 4. This is for ordinary body. This is all about the formulae. These formulae we can utilize while solving the numerical problem. Thank you.